This is a Christmas tree ornament that Lily and I made this past winter. The goal of the project was to create a visually appealing ornament that utilized a simple, battery-powered microcontroller to sequence LEDs. There is a power switch and a mode button on the back. Turning on the power switch makes the ornament go into the first sequence, and pressing the button changes through the different modes of illumination. Of course, this could easily be reprogrammed to do much cooler things, and it was a goal of ours to publish planned and source code in the hopes that some of the people who receive this gift would try to reprogram it themselves. We designed this as a 4-layer board where the voltage rails are on the inside layers, most of the routing is done on the component side, and the other side is almost purely copper, with no traces, and pads only for the LEDs. One of the tricks that we used was to hide vias under the LED pads. The EDA was done in KiCad, while the design of the tree, the presents, and the placement of the LEDs was done in SOLIDWORKS. We imported that geometry into KiCad for the cutout of the board and for the details that we designed using solder mask and gold plating. One big achievement of this project was designing a boost converter circuit that would convert the voltage of one AAA battery into a stable 3.3 volts. The board consumes about 20 milliamps of current on the 3.3 volt rail when all the lights are lit, and we were happy to be able to design something that would last for over a whole week with the lights constantly on. Another goal of this project was to design programming pads and a programmer that would allow the microcontroller to be programmed after installation. For the microcontroller, we used an ATtiny 84A with an Arduino core, allowing us to do all of the programming in the Arduino IDE. We chose to design programming pads into the back of the PCB that match the presents on the front of the ornament. Programming was achieved using an Arduino Pro Mini as an ISP, and a custom programmer using flat alligator clips that would not damage the gold plating. Finally, this was a great project to learn about surface mount electronics design and surface mount soldering. Using entirely surface mountable components really helped establish the look of this board, given that nothing protrudes through it. To assemble the boards, we used a $20 hot plate from Amazon along with solder paste to solder the components onto the back side of the board. Then we mounted the board into a vise using custom soft jaws and hand soldered on the surface mount LEDs to the top of the board. Overall, this is a thrilling project from start to finish, and we will definitely use the techniques we've learned from this project in the future.